Welcome back to FE Exam Prep for Mechanical Engineers. Today we'll be talking about bearings with a conceptual review and a practice problem. This concept pertains to mechanical design and analysis section of the exam. Starting with a review, the key components for bearings that you should know about in the exam include the inner ring, rolling elements, cage, and outer ring. The inner ring is right here, and it fits over the shaft. The rolling elements are right here. They can be in many shapes and sizes, but they roll along the inner and outer rings. The cage is the frame that keeps the rollers separated so that they don't hit each other when the bearing is actually in its application. And then the outer ring mounts to the machine housing or like an outside structure. So that would be this here. Other components of bearing manufacturing and applications include lubrication seals, truss plates, etc., but they're not necessary for the exam unless you were to go into that industry. The other thing you should know about for the exam is the difference between a radial and an axial load. Radial loads are perpendicular to the shaft, so that would be like anything coming off of the shaft like this, and they act along the circumference of the bearing. The axial loads are parallel to the shaft, and they kind of act along the face of the inner and outer rings, more like the flat sides of the bearing. Here's an example of bearing applications, and these are the two that will likely be referenced on the exam. Bearing types are differentiated by the roller geometry, and different geometries are selected to perform better in specific applications. So here on the left we have the ball bearing. The roller elements, right here, are spherical shaped. That means the point of contact, or they have a point contact, which means that where the bearing interfaces with each of the inner and outer rings is just going to be a single point. Since there is not too much material interface there, it creates low friction. Since there's also not much interface there, the bearing can really only accommodate low to moderate loads, and it has a low thrust capacity. Low friction contributes to high speeds, so ball bearings are typically used to reduce friction and improve efficiency. Then if you switch over to the other side, we have a tapered roller bearing with a unique rolling element. It's kind of like a cylinder, but the angles are, or the edges of the cylinder are tapered, so the diameter is smaller on one end than it is on the other. Compared to a ball bearing, they have a linear contact point. So where the bearing interfaces with the inner and outer rings can be defined by a line. So this creates more friction, but it also allows the bearing to withstand heavier loading. And tapered roller bearings are unique in that they can accommodate heavy combined loading in both the radial and axial directions, with the trade-off that they can handle lower to moderate speeds. In summary, they are used to accommodate heavy combined loading and high stress forces. Here are the formulas that are used in the FE exam reference manual. First one is the basic load rating equation, which calculates the theoretical life of the bearing before it begins to fail. This formula is defined on the right here, and it depends on the minimum required basic load rating, the design radial load, the design life in millions of revolutions, and a constant A. This will become much more simple to understand once we do our practice problem. Another equation is the equivalent radial load equation, which determines the theoretical radial load that causes the same amount of fatigue damage as the separate radial and axial forces acting on the bearing. So it's just a simplified load that is actually used as an input to the basic load rate equation. Okay. There's one more one more formula in the reference manual for deep groove ball bearings here. We won't cover that today, but it will be in another video. All right, let's go with the practice problem. So here we have a ball bearing that has a basic dynamic load rating of 25 kilonewtons, actual radial load of 3 kilonewtons, and actual axial load of 2 kilonewtons. The bearing factors are x equals 0.56 and y equals 1.4. The question is to determine the expected bearing life in millions of revolutions, assuming that the inner ring rotates. So the first step of this problem is to find the equivalent radial load using the equation on the left. We're provided x, which is equal to 0.56, y, which is equal to 1.4, v, which is equal to 1.0, because the inner ring rotates, Fr is the force in the radial direction, which is 3 kilonewtons, and Fa is the force in the axial direction, which is 2 kilonewtons. Most of these variables were found in the problem statement except for V here, kind of skipped over in my explanation, but V is equal to 1 if the inner ring rotates, and V is equal to 1.2 if the outer ring rotates. Typically for bearing applications, either the inner or the outer ring is going to rotate and the other one will be fixed, and that's determined by how it's installed, basically. These V constants, not sure if they'll be provided on the exam. They're certainly not included in the reference manual, so it's something to keep on the back of your mind as you're going into the exam. If I were to plug in all of these variables, I would find that the equivalent radial load is 4.48 kilonewtons. Okay, now I can go into step 2 of the problem, which is to actually determine expected bearing life in millions of revolutions. Since we have a ball bearing, A is going to be equal to 3. We're provided the basic dynamic load rating, which is C, of 25 kilonewtons. And we solved for P in the first step of the problem. So now let's rearrange for L, that's what we want to know, here, and plug in. L is going to be equal to C over P to the power of A. Plugging that in, we'll have 25 kilonewtons all over 4.48 kilonewtons to the third. And we get our final solution of 173.8 million revolutions. I'll do this in different. Let's highlight this in a different color as the solution. Okay, so that wraps up our review of bearings. In summary, bearings have 4 key components that you should know about. You can classify them by understanding how well they can accommodate radial and axial loading. The ball bearing and the tapered roll bearing are going to be 2 key bearing types or classifications that you should be familiar with. Here are 2 of 3 bearing equations included in the FE reference manual. Third one we'll review it in another video, and here's a simple problem that uses both of the equations. I'd say that you don't need to be a bearing expert. You're pretty much probably just going to be asked to plug and chug for these equations. I hope that helped and make you feel a little more confident going into the exam. Thank you.